Mathematical induction. We'll get a few problems done, and then we'll probably continue with this tomorrow. We're looking at a test. My guess is like next Monday, Tuesday-ish. Okay? So anyway, we're going to talk about proof by mathematical induction. It was first published by Richard Dedekind in 1887. So this is what it mathematically is probably pretty recent. Okay, because it was in the 1800s, and so 1887. So when you think about that, it was 25 years ago that this was first published. And so first of all, we have two steps with the proof by mathematical induction. We have showing the statement is true for n equals 1, and then assuming the statement is true for n equals k, and then showing the statement is true for n equals k plus 1. So we've got two things for the proof by mathematical induction. So we're going to go ahead and jump right in with the proof. Okay, and so what's going to happen is, obviously these are going to take a little longer, and so you're going to take up a little more room on your paper. But the first step is we are going to show the statement is true for n equals 1. So basically what this means is you're going to go ahead and find n, and you're going to plug in 1 for n. That's your very first step. Okay, so very first step is find n and plug in 1 for n. So if you look here, I see an n right here. So I'm going to plug in 1 for it. I'm going to disregard the 1, 3, and 5, and I'm just going to focus right here on the 2n plus 1. So I've got 2 times 1 minus 1 equals, here's another n. So on the right side, what is it going to be? 1 squared. So let's go ahead and look at this statement. 2 times 1 minus 1 is what? 1 equals 1. Okay, good. We've shown the statement is true for n equals 1. That's the very first step. Everybody should be able to handle that. The second step is to assume the statement is true for n equals k. So what that means is I want you to replace n with k. So all you're going to do is duplicate the statement, and in place of n, you're going to put k. Now, if you remember, the next part of it said show the statement is true for n equals k plus 1. So we want to show that 1 plus 3 plus 5 plus dot 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 plus 2k minus 1 plus 2 times k plus 1 minus 1 equals k plus 1 squared. Now I'm going to let you get that down, and then we're going to talk about where all those came from. Now, when I think about k, that just means a term. So k could be my 100th term, right? What would k plus 1 be? 101st. So what I did here when I wrote them in green is I wrote to the 100th term per se, and then I added one additional term. So this right here is one additional term. Okay, so this is all the way up to k, and then this is k plus 1. So this is like 100, this is like 101. So that's what you're going to do every time. And so now our task is going to be to show that this is a true statement, that left equals right. So now when all is said and done, I need to have the left equal the right. So now the question is, looking at this, how can I even begin to start? I have to get whatever's on the left equal to whatever's on the right.
Add square root.
So basically, I need to show that the left equals this. Right? Because that's what k plus 1 squared is. So what causes a bunch of trouble over there on that left side? The dots. The dots cause trouble, right? Ultimately, these dots cause trouble. And so what I want you to do is I want you to think if there's some way that I could rewrite what I just underlined in yellow.
9, that was for the 9, dot, dot, dot. No,
And
Isn't 2k plus 1, doesn't that equal all of it?
What does it equal?
Like, if you put a number in, you just write,
Oh, it was
Okay.
equal.
it's like 1 minus.
Why does it equal k squared? Because of that statement right there.
Oh, yeah.
Ah. So what we're going to do is we're going to replace that with k squared. And so then now I'm going to go ahead and add. What I'm going to do here is distribute the 2. So I end up having 2k plus 2 minus 1.
2 plus 2.
Ah,
Dot.
but what do we know that equals? K squared plus 2k plus 1 equals k squared plus 2k plus 1. Now since this is a proof, we put a little box, remember? Now what we're going to do is we're going to go ahead and continue with this tomorrow. This is kind of an intro. I'm going to do 2 more problems tomorrow. And then if you want to go ahead and get started on your homework, page 625, 1, 2, 4, and 5. Now this will actually be due Wednesday. Okay, this will be due Wednesday. Okay, so